Hi everybody, today I'm going to show how you can use this BMW seat with this controller without the car. Now, you can use it just connecting the battery using the brown wire from this harness here. The brown one is the negative and the red one is the positive. The small one is the K-bus signal. If you only put the battery wires in, you can use it manually with the memory, but only the previously set memory, or manually just control all the positions. But you cannot set the memory, and you cannot use the one-touch memory setting. Okay, now using the Arduino, I'm going to show later on. It's an Arduino Pro Mini and a little PCB that I made. I'm going to explain the circuitry and everything later on, and the code. Now, if you put the digital pin 3 here, let's see if I can show it. I think so. If you ground the digital pin 3, now we have memory and we have one touch. If you put it on the 4th digital pin, we have memory, but sorry, I don't think it went. There you go. Now we don't have the one touch setting, just memory, but no one touch. And digital pin 2 would be key off, and we don't have memory again. Now, key off is 2, accessory is 3, and ignition is 4. For safety reasons, BMW don't allow the memory seats to work with one-touch operation on the memory when the car is in ignition, because if you are driving and you just for some reason press the button, the seat would just start moving while you are driving, and that would be very dangerous. But when you set the key on accessories, that would be fine and no problem. So that's why we have these 3 options. And the other one would be, if you don't have the key, you cannot just write the memory. So for now, on this seat, that's it. The 3 wires here and this little board. Now I'm going to show the hardware part and later on the code. Hi, so this is the second part of the video. In this part I'm going to show the hardware part of it. First of all, I'm going to talk a little bit about diodes, because that's something that on the very beginning, the early days that I started working with electronics, I have some difficulty figuring out the polarity of it. So, one thing that I'm always use now and makes my life easier, I know if you just work with electronics for a long time, you're going to say, oh, I already knew that. But then again, if you don't, I'm going to explain anyway. Now, here we have a diode. You can see the little strip here. Usually on a circuitry, you would have a little arrow here, like this, pointing towards the strip. Now, if you want the current to flow through it, you just point it to the negative. If you're pointing to the negative, the current will flow this way. If it were the other way around, the current coming from here would not pass through this. Here we have a positive wire, and we are pointing to the negative, because positive is going through this. Now, if you are using a relay, for example, and you want to have a reverse current protection, you would use it the other way around. So let's say you had a positive here from the relay, and you had a negative on this side, and this one would be connected to this other lead from the relay. Now, in this case, you would have this diode the other way around, because when the relay is switched off, there are some reverse current that would go through here, because this one would be reversed, and when it's powered on, it would go the other way around, so this would be just inactive. Now, why do you use a reverse polarity protection in this case? Because if you don't have it, some current will go through and go towards your IC, your microcontroller or whatever, and will burn it. MOSFET, IGBT, whatever you're going to use, transistor, well, whatever. So that's it. So now to the hardware part of it. Now we have the Arduino will connect in these leads. Now here's the Arduino. It's an Arduino Pro Mini. For this use, since I'm going to just test it, I only needed the serial leads, and this one's for selecting the ignition off, ignition accessory, and ignition options that I showed on the first part of this video. So that's why I just put these leads on this one. This is a very old one, it's already soldered everywhere, well, it works, that's what matters. Now, here we have an IC, that's a LIN controller, and I'm going to talk about a little bit later. Here we have a ground, LIN, since this is a LIN bus transceiver, I'm calling this pin LIN, but I'm using this case with K-bus and ground. Here we have ground, 5 volts, transmission from the Arduino to the transceiver, and receive from the from the IC to the Arduino. We are not sending anything from the C to the Arduino, so this pin is connected, but we don't use it. This circuit, we can use it also to sniff information from the car as a data logger or whatever. And on this side we have a regulator. It's just a standard one. It's a LM2596S. It's a 3 amp regulator. Now this little circuitry that I wouldn't even dream of saying that it will consume more than 100 milliamps. Not even that, probably something around 20 to 30 or even less than that, but on the 5 volts side. But I have used this in cars for a long time. It will cope with fluctuations from ignition coils and whatever, and will just be work awesomely. So that's what I use. I do recommend. I have in a car a little LCD screen that I built in 2015, I think. That's 6 years ago, probably even a little more. And the one that I put there is still running, no problem. Never had any kind of issues with spikes or whatever on the other side, or microcontrollers burning or whatever. And in that screen I'm using 3.3 volts, so that's even more sensitive than 5 volt Arduino. Since I'm using 5 volts, I just pulled out the potentiometer from here. This resistor, this 2 resistors is for the divider to control the output. This one is already built in. It's a 330 ohms. It's a 331 for the SMD marking, and this one is the one that I put on here. It's a 1K resistor. It's a 102, and we'll be outputting here 4.96 volts, I think, something like that. And since this is a switching IC and not a regulator, you will have way less heat dissipation and power loss than if you used, let's say, a 7805 IC. So that's why I'm using this also, and it's protected for reverse current and etc. So that's it. So that's it from this side. In the middle here, there are no bridges, nothing, just space and the 4 wires for the regulator on the other side. That's it. So that's why this is soldered, so I will not be able to show this side, but again, there's nothing there. Now, we have 3 LEDs. This is 5 volts, this is 12 volts, and this is LIN data send or receive. We have here 1, 2, 3 pull-ups, this one and this one is 4.7 kiloohms for the receive and send signals, and this one is a 100 ohms resistor for the sleep signal that I will be talking from the datasheet. So the IC is this one, TJA1021. It's a LIN transceiver, but it is compatible with ISO 91 something something. And because of that, you can use it with K-bus, LIN, or some other 12 volts one wire systems. For example, the Honda Dash, I'm going to make a video about that too. The LCD Dash from not so modern but kind of modern Honda Civics. They use, basically it's serial over one wire 12 volts. It's basically ISO 91 something something. So that's ISO 91 something something. So that's it. Now, here we have this. I'm going to just turn so the pins will match. You can see that there's a little chamfer here that will show you the pin 1. So pin 1 is RxD. RxD is the signal coming from, I'm going to pause just to make sure that I'm not saying this wrong. Just one second. Okay, I'm back. So RxD, it's actually the signal that the transceiver, this IC, is sending out to the receive pin of the Arduino or whatever you're going to use. The TXD is the signal coming from the Arduino to the transceiver. Now, this transceiver will work with 5 volts and 3.3 volts. I am using this IC in a 3.3 volts situation on with an STM32 microcontroller for a Volkswagen LIN steering multi-function steering wheel controller to just connect it to my regular Chinese head unit. So it works fine with 3.3 and 5 volts. No worries there. Just one little thing. This IC will not work with Volkswagen KWP protocol because KWP has how can I put it? It has a wake up signal that it's somewhat long, and this IC will just drop the connection and will not be able to finish the wake up signal because it's based on LIN, and LIN doesn't have that. It's 13 bits high to wake up, and that's it. You don't need to have I believe that KWP, it's like 1 second, 2 seconds. It's a very big time that they use, so that's not the case. Okay, here we have ANH. ANH, it's just an output controlled by wake up signal. The wake up signal, it's connected to the VBAT, the battery pin, because I don't need this function. So it just connects directly here. But if you control this pin, then you can turn on and off the pull up. It's a 1K 1 watt resistor to just pull up the LIN signal, the LIN lane, sorry. And that's it. So this one and this one's covered, this one and this one is covered. This one is ground, this one's covered, and this is LIN. It's the output signal, goes towards this pin and pulls up with this resistor. Now, I'm using a 1 watt resistor. I had some issue on the past. I have used a 1/4 watt resistor for this one. It should be okay, but it just messed up everything. I just thought that my code was bad and things were bad, but actually it was this resistor. I just would find the resistance here, measure the resistance here, and it was just off. So I'm using a 1 watt, so I don't have any kind of issues. But then again, that's just something that I do and works fine, so I would advise you to do the same. This resistor is a 100 ohms resistor. It comes from from the 5-volt lane. It's just protection, a little bit of protection resistor that goes to the sleep signal. This again, I'm not using. I could connect it to the microcontroller so I can wake up and sleep this little IC, but I just have no use for it, so I just pulled up and that's it. I can also use this header here, connecting to I don't have it here, but then again, okay. Whatever USB to serial module, and then you can just connect to your computer and just read the signal from the car without the Arduino. So that's it for this little board here. I believe that I covered everything here, and now I'm going to just go to the hardware, to the software part of things. Hi, now I'm back on the code part of things, but first I'm going to talk a little bit about the hardware part that I forgot to tell you. First of all, whenever you're working with communication in a card, in a working card, you shouldn't uh, go overboard with sending signals unless you really know what you're doing. But you can receive them, you can use that board that I showed to sniff the information for a data logger, whatever, but you just send something if you really know what you're doing, because you can mess up a lot of things in your car, even pop the airbags and other bad stuff. So just if you know what you're doing, okay. If not, just receive the data and read it. And if you're going to use that board to read, you should take the 1K resistor off, because you already have a pull-up on the system, so you don't need that pull-up on that board too. You're going to just make the resistance, the pull-up resistance 500 ohms, and that might be too much for some of the controllers. So that I'm talking about Lin. So that's it. Now to the code. Here's it. It's just one page. There's not much to tell you. You have these 3 lines here. This is the ignition of serial data, ignition accessories, and ignition, and that's it. You have the sending ID 0x80 4 bytes, and then you have the data and the checksum here. Now this is the only byte that changes when you have a different key position. You have some pull-ups here, some pin mode pull-ups, just so you can select the modes, or how I showed you on the first part of this video, where you have the to ground the digital pin 2, 3, 4. This 5 and 6 I have not used it. I just found this data in the internet, so I just tried it. It works somewhat, but I found it useless for what I wanted. So this is it on this part. Now, the serial part of things, you need to put the bound rate at 9600 and the serial at 8 bits, even 1 stop bit, and that's it. Here I just have some ifs to read if the digital pen signal is low on one of these, and then just change the selected value, and blinks for 200 milliseconds the LED, so you know that your input was red. And here it's 1 second timer to send it every second the data, because if you go over 60 seconds without data on the bus, it will go to sleep mode and stop working. Here by standard I have selected the 2, and the 2 is the ignition accessory, so it's one touch and memory working as a default. So since I was going just to test the seat, I just put it directly so it's easier, don't need to be messing with the grounding the other wires. So that's it. And the other ones would be selected, if you could select it as 1 ignition off, 3 ignition, and these 2 that I just haven't used. So that's it. There's not much more to tell you, and thank you for watching, and I will try to put some more videos.